Welcome to the presentation on image analysis of the elbow. We're going to talk about the common projections of the AP, internal and external oblique, and the lateral projection. We're going to review the analysis guidelines and common positioning errors. Let's start with the AP elbow projection. Image analysis guidelines for the AP elbow projections state that the medial and lateral humeral epicondyles are to be demonstrated in profile. 1/8 of the radial head should superimpose the ulna. The radial tuberosity should be demonstrated in profile medially. Radius and ulna are parallel. The elbow joint space should be demonstrated as open. The radial head articulating surface is not demonstrated. The olecranon process should be situated within the olecranon fossa. The elbow joint should be demonstrated in the center of the exposure field. The elbow joint, 1/4 of the proximal forearm and distal humerus, and the lateral soft tissue should all be included within the exposure field. Here are those guidelines for your review. So let's take a look at the effects of improper positioning for the AP projection of the elbow. When the humeral epicondyles are not positioned in profile for the AP elbow projection, the elbow is more likely rotated, okay? If more than 1/8 of an inch of the radial head is superimposed over the ulna, that'll indicate that there's some internal elbow rotation. Conversely, if there is less than 1/8 of an inch of the radial head superimposing over the ulna, then the elbow is an external rotation. In order to get proper positioning, we must ensure that the humeral epicondyles are parallel with the IR. Go ahead and review this first AP elbow practice analysis and answer the following question. So let's look at this elbow practice analysis together. First, you want to make sure that you have obtained all the vital anatomy that is required for the projection. In this case, we have the elbow joint and the surrounding soft tissues. Next, we want to take a look at the anatomy. When analyzing this image, we want to look at the position of the radial head. The radial head is superimposing more than 1/8 of the ulna. In this case, that is indicative of the elbow being medially rotated. In order to correct this imaging error, or positioning error, I should say, we need to externally rotate the elbow until the humeral epicondyles are parallel with the image receptor. Go ahead and take a minute to analyze this image and answer the following question. Let's review this practice analysis together. Again, you want to make sure that you have all your anatomic structures that are required for the projection, with which we do. Next, you want to take a look for the AP projection at the position of the radial head. In this case, less than 1/8 of the radial head superimposes the ulna. This should identify to you that we are in the elbow is laterally rotated. You can see that the humeral epicondyles aren't in profile like we would like to see them. In order to correct this imaging error, we want to internally rotate the elbow until the humeral epicondyles are parallel with the image receptor. Take a moment to analyze this practice analysis and answer the following question. So let's take a look at this practice analysis together. Again, always make sure that you obtain the anatomy necessary for the projection. But I want to talk a little bit to you about elbow flexion in the AP elbow projection. We didn't talk about it much earlier, but I don't have a lot of imaging, unfortunately, on it. So let's dive into this. Elbow flexion in the AP elbow projection can cause for shortening of elbow structures and separation of the olecranon from the olecranon process, as you can see here. The degree of foreshortening depends on the positioning of the humerus and the forearm relative to the IR, okay? When the humerus is positioned parallel to the IR and the distal forearm is elevated, as seen in this projection here, the resulting image demonstrates an undistorted distal humerus, a foreshortened proximal forearm, and a closed elbow joint. In addition, the articulating surface of the radial head is seen partially on end. In order to correct this imaging error, we need to fully extend the elbow if possible and take a second projection with the forearm parallel to the IR. Unfortunately, I don't have an image of it, but in contrast, or conversely, when the forearm is positioned parallel to the IR, the proximal humerus is elevated, the projection will reveal as an undistorted distal forearm, an open elbow joint space, and a foreshortened distal humerus. Again, if the elbow joint space is closed, or the anatomy is distorted or foreshortened, I should say, we should know that we need to extend the elbow so that it is parallel with the IR. Both the proximal and the proximal humerus and distal forearm here should be in alignment. So let's move on to the AP elbow oblique projections. Image analysis guidelines for the AP oblique projection, the medial with medial rotation, states that the coronoid process, trochlear notch, and medial aspect of the trochlea should be seen in profile. 3/4 of the radial head should superimpose the ulna. The trochlea coronoid process joint space is open. The coronoid process and articulating surface is not demonstrated. The elbow joint is at the center of the exposure field. Elbow joint, 1/4 of the proximal forearm and distal humerus and the lateral soft tissue are all included within the exposure field. Now review the image analysis guidelines for the lateral oblique projection. The capitulum and radial head should be demonstrated in profile. Ulna is demonstrated without radial head, neck, and tuberosity superimposition. The radial ulnar joint is demonstrated as open. The capitulum radial head joint space is open. The radial head articulating surface is not demonstrated. The elbow joint is at the center of the exposure field, and the elbow joint, 1/4 of the proximal forearm and distal humerus, and the lateral soft tissue are all included within the exposure field. Here are those image analysis guidelines for your review. So let's discuss the medial oblique elbow projection in the context of insufficient versus excessive obliquity. Proper positioning is crucial for an accurate medial oblique projection. The degree of obliquity affects the relationship between the radial head and ulna. When the humeral epicondyles are positioned at less than 45 degrees of obliquity with the IR, there is insufficient medial obliquity. As a result, less than 3/4 of the radial head superimposes the ulna. Conversely, when the humeral epicondyles are positioned at more than 45 degrees of obliquity, this is excessive medial obliquity. In this case, more than 3/4 of the radial head superimposes the ulna. Ensuring that the correct degree of that 45 degree of obliquity is achieved is essential for achieving an optimal medial oblique elbow projection. So now let's discuss the lateral projection in terms of insufficient or excessive obliquity. Accurate positioning is essential for obtaining a proper lateral oblique elbow projection. The degree of obliquity affects the alignment of key anatomic structures. If the humeral epicondyles are positioned at less than 45 degrees of obliquity with the IR, there is insufficient lateral obliquity. In this case, the radial head and or the radial tuberosity will still partially be superimposing over the ulna. On the other hand, if the humeral epicondyles are positioned at more than that 45 degrees of obliquity, this is when excessive lateral obliquity occurs. As a result, the coronoid process partially superimposes the radial head, and there is no superimposition between the radial tuberosity and the ulna. Additionally, the radial tuberosity is no longer in partial profile. Ensuring that the correct 45 degree obliquity is key to obtaining an optimal lateral oblique elbow projection. Go ahead and review this practice analysis and answer the following question. So let's review this practice analysis together. First, we want to look at whether or not we obtain all over the anatomic structures that are required of the projection. This is an AP lateral oblique projection. We're looking for an open joint space, and we're looking for the humeral epicondyles to be in that 45 degree oblique. When analyzing this image, you want to look at the relationship between the capitulum and radial joint space. In this case, it is closed. This indicates that the forearm is not parallel with the IR. The forearm and elbow joint are not extended like they should be. The radial articulating surface is also shown. So in this case, we need to fully extend the elbow in order to get that joint space open. Go ahead and review this AP medial oblique practice analysis and answer the following question. Let's review this practice analysis together. First, you want to ensure that all the anatomic structures are present that we are trying to image, and they are. Next, we want to look at the relationship of the radius and ulna have in this medial oblique projection. in a internal oblique, 3/4 of the radial head should superimpose the ulna. In this case, the radial head's fully superimposed by the ulna. This should indicate to you that we are in excessive obliquity. In order to correct this imaging error, we need to decrease that internal obliquity until the humeral epicondyles are parallel with the IR. Go ahead and review this practice analysis, this lateral oblique elbow, and answer the following question. Let's review this AP lateral oblique elbow practice analysis together. When looking at this projection, you should automatically identify if we have all these structures that are required. Then we should move on to identifying the anatomic relationships. In a lateral oblique, we should be looking at the relationship between the radial head, neck, and tuberosity and the ulna. In this case, in a lateral oblique, they should be free of superimposition of the ulna. In this projection, the radial head, neck, and tuberosity are partially superimposing over the ulna. This should indicate to you that we are under rotated. We need to increase that degree of obliquity until the humeral epicondyles are 45 degrees with the IR to ensure proper positioning. Now let's move on to the lateral projection of the elbow. Image analysis guidelines for the lateral elbow projection state that the elbow should be flexed in a 90-degree angle. The humerus should demonstrate 3 concentric arcs, which are formed by the trochlear sulcus, the capitulum, and medial trochlea. In this context, an arc refers to a curved radiographic outline formed by specific anatomic structures such as that trochlear sulcus, capitulum, and medial trochlea. These structures are used to identify if the elbow is positioned correctly in this lateral projection. These arcs appear as smooth, concentric curves on the X-ray and are used again to assess proper alignment. Additional guidelines include, as far as the humerus positioning, the distal surfaces of the capitulum and medial trochlea should be nearly aligned. The anterior surfaces of the radial head and the coronoid process are aligned. When referencing the forearm positioning, the elbow joint should be demonstrated as open. The anterior surfaces of the capitulum and medial trochlea are near aligned. The proximal surfaces of the radial head and coronoid process are aligned. The radial tuberosity is not demonstrated in profile. The elbow joint is at the center of the exposure field. The elbow joint, 1/4 of the proximal forearm and distal humerus, and the lateral soft tissue are all to be included within the exposure field. Here are those guidelines for your review. Proper positioning of the proximal humerus is essential for an accurate lateral elbow projection. Incorrect elevation or depression of the humerus can misalign anatomic structures. When the proximal humerus is elevated, as seen here, the distal surface of the capitulum appears too far distal in relation to the distal surface of the medial trochlea. Additionally, the radial head is positioned too far posteriorly to the coronoid process. Conversely, if the proximal humerus is depressed, the distal capitulum will appear too far proximal in relation to the distal trochlea. In this case, the radial head is then positioned too far anterior to the coronoid process. Ensuring proper humeral positioning and helps maintain the accurate anatomic relationships and improves your diagnostic quality of the radiograph. So now let's talk about what happens or what anatomic misalignments occur when the distal forearm is depressed or elevated. When the distal forearm is positioned too close to the image receptor or depressed, the capitulum will appear anterior to the medial trochlea. Additionally, the radial head is positioned too far distally in relationship to the coronoid process. When describing distal forearm depression, it's like imagining that the hand is lower than the proximal forearm. Conversely, if the distal forearm is elevated or the hand is higher than the elbow, in alignment here from the IR receptor, the capitulum will shift posterior in relation to the medial trochlea. In this case, the radial head appears too proximal to the coronoid process. Again, ensuring correct forearm positioning is essential for maintaining proper anatomic relationships and achieving that high quality diagnostic image we are looking for. Let's talk about wrist rotation. In order to achieve a true lateral elbow, the wrist should be in a true lateral. In a true lateral wrist or elbow projection, with the wrist in a lateral position, this situates the radial tuberosity on the medial aspect of the radius, where it is superimposed by the radius and is not demonstrated in profile. However, when there is wrist rotation, the tuberosity will become in profile partially. In external wrist rotation, this rotates the radial tuberosity towards the anterior surface of the arm, where it is partially demonstrated in profile anteriorly. In internal rotation, this rotates the radial tuberosity towards the posterior arm surface, demonstrating the tuberosity in full or partial profile posteriorly. Go ahead and review this practice analysis and complete the following question. So let's review this practice analysis together. First, you want to ensure that you've obtained the anatomy that is required for the lateral projection. In this case, we have an elbow on here. However, is it positioned appropriately? In my opinion, it is not. We need to see an open elbow joint. There is no open elbow joint. The position of the radius and ulna is indicative of some elevation problems. If you take a closer look here, the radial head is positioned too far posterior to that coronoid process. Also, the distal capitulum is shown too far distally from the medial trochlea. This indicates that the proximal humerus is elevated in comparison to the distal humerus. In order to correct this positioning error, we need to get the entire arm in the same plane. So we need to depress that proximal humerus until the humeral epicondyles are superimposed. Go ahead and review this next practice analysis and answer the following question. So let's dive into this practice analysis. First, you want to look for an open elbow joint, with which we do not have. Next, we should be seeing that the humeral epicondyles should be superimposed, and they aren't. And the relationship of your radial head. In this case, the radial head is anterior to the coronoid process. The radial head moved away from the ulna. When it moves away from the ulna, this should be indicative to you that the proximal humerus is depressed. Basically, the elbow is placed higher than the proximal humerus. In addition, the capitulum is too far proximal to the medial trochlea, another key indicator to proximal humor, the proximal humerus being depressed. In order to correct this, we need to get that entire humerus in the same plane. So we need to elevate that proximal humerus until the humeral epicondyles are superimposed. Go ahead and review this practice analysis and answer the following question. Let's review this lateral elbow practice analysis. When looking at this projection, you definitely want to see if you have an elbow joint. In this case, we do have a little bit more of an elbow joint than we saw in the previous two practice analysis. It looks as though the condyles, the epicondyles of the humerus are nearly superimposed. However, there's still some type of positioning error happening here. In this case, the position of the radial head is actually distal to the coronoid process, and the capitulum is too far anterior to the medial trochlea. This should indicate to you that the humerus is in the same plane. However, that distal forearm is depressed. The hand is lower than the elbow. In order to correct this imaging error, we need to elevate that distal forearm until the humeral epicondyles are superimposed. Go ahead and review this practice analysis and answer the following question. Again, let's analyze this image together. With looking at this projection, you can tell that the humeral epicondyles are nearly superimposed here. However, we still have some type of positioning error happening. When analyzing the position of the radial head is proximal to the coronoid process. It almost looks like it's pushed up into the joint space. The capitulum is too far posterior to the medial trochlea. This should indicate to you that my humerus is in the same plane, but I have a distal forearm elevation problem. And so in this projection, the hand is basically higher than the elbow. This pushes that anatomy more proximal. To correct this, we need to get that distal forearm depressed until the humeral epicondyles are superimposed. This completes our image analysis for the elbow. If you have any questions, please feel free to reach out to me via email or at clinic. Thank you.